what we did here today is I asked each individual subgroup to send some slides with their own updates, mostly focused on accomplishments so far, challenges that each subgroup is facing so far as well, and maybe some discussion points that we're not going to tackle now, but probably during the individual breakout sessions later on. So before we get into each individual presentation there, this is the name and the main objective of this field trial, right? Of this objective in the field trial that we have in Ashland Bottoms, there near Manhattan, and also in El Reno with the USDA in Oklahoma. And here what we're looking at is essentially, as Chuck mentioned, 17 different rotations, right? That yellow one up on the top is our baseline. So essentially it's a continuous wheat system, right? Wheat planted after wheat, just with a short summer fallow in between. The two blue lines that come after, they are our adaptive treatments. So we have an adaptive forage and an adaptive grain as well. And in those, we can actually take decisions on the go in terms of changing based on weather conditions, changing crops based on prices and everything. And from there on, we go into more and more intensive systems. So we have a semi-intensive, those two different roles, they are actually nitrogen management there. And we have two as well on each, because in each year, right, we want every phase of the rotation to repeat on every year. So that's why we have essentially 4 out there for the semi-intensive, normal or progressive nitrogen, right? Then we have our intensive rotation. So we're getting more and more intense in terms of how many crops we're trying to grow every year. And here we have dual purpose systems along the same lines, semi-intensive and intensive, and one with the green nitrogen as well. We're trying to grow some legumes and see if they would be a good fit in the rotation there. Right now, we are at that gray bar or gray column that you see up there. That's what's planted now in the field, at least. Some of these may vary a little bit from El Reno, but that's where we are in the rotation. So going into just harvested the third year of the wheat crop there. Very well, getting into the wheat crop, the winter crop reports here. And so next I have summer crops. So I guess, Ignacio, if you don't mind talking about yours there in a little bit. Then we have forage crops, food, and then the soils, right? So those are some of the accomplishments there, right? We have a first paper submitted that's actually not from data from the rain trial, but from some long-term rotation that we had in Ashland as well that complemented very well what we were looking at in the rain project. Third year of the wheat crop, harvested successfully. We really don't have any missing data so far, at least for the wheat crop. Last meeting, we discussed the possibility of adding some canola to diversify there in the winter. We didn't have a good stand, so we went back and replanted wheat in those plots where we didn't get a good canola stand for this last year here. You can see we have a range of planting dates from early October to late November there, and that's again just whenever we can get in there because of those different rotations. That creates a very large range in planting dates for wheat, which causes large yield differences as well. So quite a bit of variability in the data, which is excellent for what we're looking at here. We also have an ancillary study that we're working with Justin Knopf on trying to understand how different wheat varieties rank in terms of previous crop. So whether we're following a wheat crop, a soybean crop, or a cover crop, right? How do those 30 different wheat varieties rank? And should we be considering that when we're doing a variety selection? And absolutely, thanks to Anita's group there, improved weed control plan. I didn't bring it here, but it looks pretty complex, especially if you're outside of weed science there. Some challenges, of course, with some of this very late planting getting to November 22nd there. It's kind of sometimes hard to get a good stand. Grassy weeds in the wheat crop has been an issue as well. So that's a point of discussion that I have brought here in terms of should we be considering a different variety that allows us to go with some rest control and herbicide in the wheat phase. One thing that affects the summer crop is harvesting of the bulk wheat. So for us, we go there and we collect data from a swath inside that plot, a 5-feet swath, whereas the plot is 40 wide. And then we have a commercial combine come back and cut the rest of the plot. And that sometimes takes 7 to 10 days. And so that's really delaying the summer crop planting more than it should. and some issue with triticale hay emerging in the summer crop as well. So this is an aerial view of the experiment this season on 12th of June. We have there our baseline wheat crop. You can really tell the differences in maturity, although the light is not great here. There we have wheat that was harvested for hay already, so there's some soybean growing there. Wheat sown very late, you can see how much greener it is. So we have very large differences in phenology, which is actually going to be great for as this project moves along. Wheat planted late, but after soybeans, not as late as the other one. And wheat sown early as a dual purpose as well. So very a large range of systems within the wheat phase that actually creates pretty large differences in phenology as well. And here just some things on the challenges, right? So this is kind of what the plots looked like after corn when we planted on November 28th, so fairly late planting there. But you know, it's okay. It's what Chuck mentioned, some of these systems will fail, and that's why we're collecting data on these as well. This probably yielded 12, 13 bushels per acre where we had treatments yielding 50 or more. Grassy weeds in the wheat. So again, some potential for discussion here will be perhaps going with a variety that has herbicide resistance technology and perhaps a little bit earlier variety as well to allow for the summer crop group to come in and plant earlier. And then the emergence of the triticale, both in the soybean crop and also in the alfalfa crop. So these are some of the challenges that we have had. We discussed internally here, and you know, both the soybeans and the alfalfa, they are forage. So okay, should they just use this triticale as forage as well, at least in that first cut, and then it shouldn't probably come back later on. That's a quick overview of the winter phase. We're going to move on now to the summer crops phase here. So Ignacio, if you'd like to come around, please. So after Ignacio will be Hudra, Dorivar. I think that's it. Oh, we have a couple more as well.
Yeah. So many things on the summer side. I mean, we have one publication that naturally Ignacio. You will see that I mentioned Ignacio because he's one of my students. So just with one, it's not enough. So I was able to bring some second Ignacio. So he was working on this paper. We have a nice publication that we were looking at different. In fact, to compare it with Kansas and also some sections in Oklahoma, basically looking at how we can intensify rotation with using maize and what is the optimal planting time for maize. So I have been working with some farmers around the area, not much Ray on the north, but here some of the farmers are already working and intensifying systems. So they're planting, usually they tend to plant maize April 1st and they tend to harvest mid-September and then they go back with wheat. So, and then one of our hypotheses is how much yield penalty we have when we move, and then we use different maturity. So we complete that publication. So that's kind of a good step forward. Then we are finishing some of the satellite experiments that we have compared with this study. Also, we have phenology plots. So we're looking at different timing. Since this study, as Chuck was saying, is complex and very fixed. So we are trying to look and investigate different maturities and different planting dates on other studies. So we have another separate study that we're looking at investigating planting dates and maturity. So we collected data, nothing missing, so that's excellent. So some men, I will probably move immediately to the challenges. One of the main challenges Romulo mentioned is delay of planting dates. So I was chatting last week with Ray. If we are, for example, this year is one of the examples. So we were, I think that wheat was ready last week of June, and then it happens last year again. So it took us 2 weeks to get our plot planted. And this is something that in many situations a farmer will never happen. Ray will have the combine and then immediately the planter behind. And that is the way it should be. So we are also looking at potentially one of the things that we are discussing is to understand, for example, these 7 to 10 days, 14 days in the season in the summer are tremendous. And the difference that you might get there, probably you go from 120 bushels to 70. So it's not really like we are missing just a few days. It's just we are missing the entire season almost there. Because those 14 days in the summer are basically similar to be a month during the end of the season. So just to give you an idea of the importance of being more on time on that. And this is one of the comments that from my opinion, the planting data we are using today is not realistic compared to farmers. And we still have a lot of weed pressure. I know that we have done a better job, but still it's quite challenging because to manage all the weeds on the summer and then the amount of seeds, and weed seeds that we have there in Ashland, and the seed pressure is tremendous, during the summer. So this is something that, this was last year I planted, 2021. It's interesting because we start seeing more and more farmers, planting late. So if you just, for the guys that were driving probably from both sides, from Manhattan or from Oklahoma, you start seeing what's going on if you plant too early. So this is one of the years that show us what happens if you plant too early corn, as with the mentality of the Midwest, that if thinking that you are in Illinois, Indiana, when we are in Kansas, Oklahoma. In many situations, early planted corn, in some of the places around here, many of the farmers around here, they were chopping the corn. So that corn is out of the game. And that's what happens on corn. It takes only 14 days around flowering that if we don't have precipitation, if you have high temperature, you lose 60% of the yields. And after that, what? So one of the things that we started thinking, exploring is how late can we plant corn? And then we have a few farmers that are already thinking on this. Of course, nothing to recommend because this was extremely late planted. And we did it on purpose with the idea of showing if we can do this, that means that we can plant it. Okay. This was first week of July. Flowering was September 8th. Maturity was the end of October, and it was 70 bushel. The other points that we start exploring more, and then this we're working with the phenology plots. Most of the corn bred for this area is usually between 100 and 115 days. And many of the corn that is above 115 and below 100 usually haven't been tested for the region. So, and there are different germplasms, so it's not exactly the same. So we're trying to understand what happened when we start changing maturity groups and changing planting dates. And most likely, many of this data is not available because first, from the breeding standpoint, most of the breeding has been focused on 100 and 115 days because that's the most commercial corn available. And then when you look at breeding or looking at 98s, 90s, 80s, all of these maturities are basically bred for Iowa, North Dakota, Michigan, Ontario, so Canada. But there are different germplasms. And so there is something that we still need to explore to see, what are the things that we can do? The other concept that we also kind of try to demystify is like late planted corn needs to change on maturity. So we are seeing that in many situations that late planted corn, we probably shouldn't change any maturity. And this is similar to what we are seeing on soybeans. But again, information that is not available. When you talk to a farmer, they say, if you plant late, short your maturity group or relative maturity for corn. But we are seeing that that's not true. And in many situations, if you do that, you will lose too much yield. And at the end of the day, in terms of days, the maturity will be almost the same that if you just keep using 111 or 115. This was also now in 2022. These are some of the things that if you are coming with soybeans after cover crops, we have many situations. It's an interesting option, but also many challenges in terms of establishing the crop, making sure that I have a good way to make a row line and make sure that those plants are getting established. So these are some of the treatments that we have right now there. So it's an interesting option in terms of herbicide. I think that will reduce the weed pressure that we have there. So, and then as we mentioned, so not to get into this again, but this year we are on the same page. So we delay our planting on corn. So our planting was effective July 12th. My point on this, and to emphasize this point, is 2 weeks after the wheat harvest, but also not only the couple of weeks that we lost, but also immediately after the wheat got harvested that night or the following night, we have a rain. And then this is a problem. We didn't lose only 12 days, but we probably lose 20 days. Because after that moment that we didn't plant it, then we have 2 weeks almost of the last 2 weeks of heat and drought. So the amount of growth that we have today on that crop is almost nothing. So I'm not sure if we'll get much to maturity this year. Last year was an excellent growing season in terms of an extended fall. I don't know if we'll get the same. Yeah, I'm not too hopeful because usually those extended falls don't happen year over year. So and we have again we have high probabilities of freeze in Kansas. I mean for Manhattan already starting from the first week of October. Last year we went to October 25th, no problem. Which we usually will have at least 50-60% of high probability by October 15th on freeze. So
what's your first freeze day?
I think that the chances are very small compared using the last 30-50 years of weather data, but I think that the first is probably last week of September, like September 29th or 30th, October 1st, October 2nd, around that time. Yeah.
It's been trending longer later.
It's been trending longer, yes. And this is, when we are talking about late planted corn, on my mind is usually from a farmer perspective, it might be more around mid-June, maybe late June at the latest. This is probably extreme, but we can do it because our research grows. I will briefly, this is something that we're also doing on maize soybean intensification. So as I mentioned before, we're looking at different maturities in corn. One of our main ideas was to see if we are changing planting days or if we are changing the systems, should we start changing maturity, should we start changing densities on all the points. So what we have right now is that we have different planting times. So even next week, we are putting a planting date on this study again, just to understand what happens to the phenology of these crops when we are moving into different time of the years. And I think that we're getting a lot of really good information on trying to understand basically what happens to different maturities. In many situations, again, there is a lot of investment and research investment that has been done for breeding corn in 100-115, which is the most commercially available corn from the US. But when you look at the 75s or close to the 90s, these are different germplasm. It's not exactly the same to the most traditional. And it has less breeding improvement, which for me is attractive because in many situations can be something that if we look at something positive here, there is a lot of more potential for yield gain coming from these shorter season varieties. If you have any questions, I think that we can stop at the end for questions, but just so we don't break too much the flow.
Thank you very much. I'm Rudra working with Dr. Min for Forage Component. So under Forage Component, we have combination of 4 cropping intensity and 3 nitrogen treatments. In 2021 and 2022, we have collected 28 samples from winter crops and then 152 samples from the summer crops. All the samples were grinded and ground and then 28 different forage quality parameters analyzed using NIRS technology. We also did the forage dry material analysis, and we did not find any significant effect of cropping intensity and nitrogen treatment on forage nutritive value and also to the forage dry material. Now I'm leading to manage the alfalfa harvesting with the help of other friends. So till date in this summer, we harvested 2 times. And the major challenge is wheat. For forage, I'm also collecting the wheat samples to see how much forage nutritive value in these wheats. Because the palmer, I know that the palmer amaranth is a good source of forage in Asian country. We give that wheat to dairy cattle. Another is the Triticale regrowth in the alfalfa and forage soybean plot. I'm taking samples separately and also analyzing separately and with the combination for the forage quality. And then major discussion points for me is field management plan, because we have many works to do. Last week we did the weed control physically. So we have to harvest alfalfa every month manually, and then we have to clean the plot. But we are working in a close coordination with all the students So that's all from the forest component. If you have any question.
No, we'll do it.
Okay, okay, thank you.
That's not me, okay. Okay, good afternoon. For those of you who don't know me, I'm DorivarDiaz, soil fertility specialist, some of the new students. And so a few things, just keep it short. In terms of accomplishments, we are taking care of the nitrogen fertilizer application treatments. What Romulo described early. We have two main nitrogen management components. One is the basic, which is basically a broadcast application, one time. And then the progressive management, which is two timings. So we're putting two application times. So that's one component. We also making changes to the source. We basically put in inhibitors, urease inhibitor, nitrification inhibitor to the progressive method. We also changing the rates based on models. So time, rate, source, and placement, we are not broadcasting. We also dribble applying that. So again, so that's one of the main things there. We're really trying to be as efficient as possible in terms of putting that nitrogen. So that's one of the things that we do. We also been collecting samples, nitrogen samples during the growing season multiple times. And so that's one of the things that we accomplished as well. In terms of challenges, we do see that there's a lot of things happening in these plots, okay? And so that seems to be a little bit something that we probably need to discuss a little bit more. How is this affecting things like sensors and compaction and things like that? Is something for discussion the next couple of days. And I have to put this, my students tell me it's very difficult to collect samples when it is dry in this with the drought we have. So I have to put that here. And so it's been pretty tough. I recognize that. I also collect soil samples sometimes. So. And so in terms of discussion points, and this may be a lot of the things we were talking with Romulo here on the way here, and didn't want to repeat a lot of the things that we already talked about. But one of the things that we realize is that we do have a lot of data coming in now. And I think we do have to be a little bit more, try to have better communication, try to avoid any potential overlaps, but most importantly, how we can all contribute and take advantage of data that's coming and make sure we are using the data. We have different students. One of the things that is, and I really appreciate, the K-State side, the students are really communicating very well, much more so than the faculty, I would say. And that's a good thing, right? Because as they're working on publications, on theses, we want to make sure we don't duplicate things. And at the same time, we're not leaving things without covering. So certainly a lot of opportunities there for, leveraging data that everybody's collecting. Okay. So that's, I think, is one, to me at least, the next day or so, Chuck, I think that would be really nice to see what others are doing. And one thing about what you mentioned, the webinar, to me was also very helpful to see what's happening. And suddenly I realized, hey, such and such is collecting this data. We can use that data to do something different. So to me, I think that would be great in the next couple of days to talk about that type of things. So health, I don't know. Thank you.
Yes, Dr. Dorivar, we agree on that. That's very hard to collect soil in this summer. Very dry. So for those who doesn't know me, my name is Cesar. I am a master's student under Dr. Chuck Rice. And about the soil health report, so I am doing some soil samples during the growing season from the crop. So I already did samples from the wheat. I am doing now for the soybeans, and I am doing for one more wheat season. And also in the summer fallow plots. So I am assessing for soil depths, so 0 to inches, 2 to 6, and 6 to 12. And those samples are linked with some crop physiological stage, so emergence, blooming, and physiological maturity. And this is to better understand how the soil health indicators behaves during the growing seasons on different crops and also in the summer fallow plots. So I am also taking samples to make like a soil health assessment regarding soil microbial community activity, organic carbon nitrogen, inorganic nitrogen, and water stable aggregates, bulk density, and soil water for the third year as this year. And we are now in next fall implementing a new study regarding nitrogen mineralization for the next fall. And I would put like one challenge is what I mentioned before, that it's pretty dry, and I think that another accomplishment that we are having during the season is the communication between the grad students is really good. We are working together in the tasks in the plot, so I think that it improved a lot. So that's it.
Okay, hello everyone. My name is Andres Patrignani. I'm an assistant professor in saltwater processes, and it's not that short, okay? We've been doing a lot of work. I just decided it was a better way of presenting all the data. So basically what we are doing is monitoring soil moisture at different soil depths. So basically in the top meter, about 3 feet, and we monitor soil moisture every 10 centimeters using a handheld soil moisture probe that we slide into some access tubes in the ground, similar to a neutron probe, but it's non-radioactive. And here we have Sophia and Joaquin. They are the ones that are going every single week to take soil moisture readings, and that's why these figures look so nice, so smooth, because it requires going pretty much every single week to capture the the recharges and the depletions of the soil moisture profile. So here what we have, we're not monitoring all 17 treatments. It would be too much time, but we are monitoring 5 key treatments that sort of represent a little bit the different cropping systems that we have. So what I decided to place is the baseline at the top and different treatments at the bottom. So as I'm passing the slides, the only one that is going to change is the bottom chart. And fonts are tiny just because there is a lot of data. So the only thing you have to know is look at the sequence of the crops at the top. And then anything that is red is dry, and anything that is blue is it's wet soil moisture conditions, which means recharge of the soil profile. And this is sort of the sequence. So this is if you are digging a trench and looking at the profile in front of you. The first thing that we noticed is, so we started taking readings about the wheat growing season in 2020. So late October, early November 2020. And we already had some crop sequences or some crops in the plots. So if you look at the baseline, we started with a summer. We had a winter wheat in 2019, right? Yeah, and so then we had the summer fallow, and then in the second week we started monitoring soil moisture. And so the first thing you see is that the top and bottom of the profile looks fairly moist. If you compare that to the second treatment, when we started with a summer crop, soybean for forage, you see that the bottom or the entire soil profile looks pretty much lighter blue. So that means that the summer crop is depleting the water, and then we are entering into the next crop with a drier soil profile. So we are sort of capturing that. The second thing that I want to, oh, okay, this is very deep. So I'm talking about that part and that part, see? So when we enter here in the winter wheat, we enter with a dry soil profile due to the water uptake from the soybean. Here, the summer fallow actually served as a way of somehow replenishing or storing water. Not very efficiently, but at least we were able to save some water. You see that then winter wheat doesn't deplete water very much the entire growing season, only the top layers, but it starts depleting water really rapidly in the root zone near the end. You see that in both. Whether it was winter wheat for hay or for grain, it starts depleting. Then during the summer, we do see a massive depletion of the soil profile. Can you guess what happened there? Usually you tend to see on the surface of the soil profile some strong depletion just because of evaporation, but here there was something else. Yes, Palmer amaranth. So it pretty much much more aggressive than wheat in much shorter time. Of course, coupled during the summer season. Then we went into another winter wheat season. Again, you can see
Too.
Oh, perfect. We start seeing the winter wheat, the depletion as we start going through the winter little bit, and then at the end you see those very nice water uptake from the root zone. You can see that the water uptake happens in the top 80 centimeters or so. So we are capturing most of that water uptake from the wheat. There might be some roots going deeper. But something interesting happened here with the winter wheat for hay. You see that there are like 2 pulses of depletion, but the winter wheat that was harvested for hay didn't have the second one, just it's because we harvested. And right after that, we had a really nice soil water recharge with the profile. So, which didn't happen in the winter wheat for grain that stayed longer in the field. So this is something to take into account as we are going into the next crop sequence. So the question is, should we go into soybean for forage, or should we take advantage of that moisture and go for soybean for yield if we have this kind of information available? I don't know. Here we have something similar. We started with cowpeas in the summer. We started with a dry profile for winter wheat. And then we go into summer fallow periods, very similar. But in this one, we didn't have we didn't harvest the winter wheat for hay, so we ended up with a very dry profile compared to the harvesting the winter wheat for hay. And now I don't know what was the yield. So these 2 are very similar, and I don't know if there was. This one seems to have a little less soil water depletion in the root zone. I don't know if that treatment had a lower winter wheat yield. We need to check that. Here there is a comparison that is interesting. Sometimes we know one of the strategies to conserve water is to switch the summer fallow to a winter fallow. And this is what we have in this treatment. We had a summer crop. So we had grain sorghum, and then we didn't plant anything. So we had a winter fallow. Interestingly, we didn't really have much recharge. Only at the very end, we started having a little bit of recharge in that winter fallow. That's just because we don't have much rainfall during the winter time. But if we get something, you can see here there was a pulse. It was stored in the profile, and then soybeans behave, as expected, starting to uptake water deeper in the root, and even going beyond 1 meter. I don't know if this is the corn that Ignacio was referring, but there seems to be a decent amount of soil water storage in the root zone for this treatment. So I don't know how that is, if the corn is going to be able to take advantage of that or not. Maybe waiting a little bit, it was not a bad idea, since right after wheat harvest there was quite a bit of dry profile. So waiting a few weeks maybe was a positive thing in terms of moisture conditions. And the last one that I have, this is pretty much the same, but the one I want to point out is this Alfalfa Triticale system. And you can see the massive amount of root zone water uptake from the Alfalfa and the Triticale, even during the winter. This is what you see right here. This is all during the winter time. And so it seems that Alfalfa Triticale is starting to pull. Well, I guess the Triticale is probably the main crop pulling out the water. And so I don't know how that's going to play in the long term for Alfalfa yield. But that was kind of interesting. So anyway, this is just a snapshot of what we are doing. We're going to keep collecting data every week during the summer and spring, maybe fall, and then we are going to slow down every 10 days or every 15 days during the winter time. But yeah, we can capture what's happening underground with this kind of intensive soil moisture monitoring strategy. That's all. That's not mine.
Okay, I'm kind of like Chuck. I don't like being tied behind this thing, but I'm going to try it. This is an update for the Grazing Lands Research Lab. For those of you who do not know me, I'm Dr. Brian Northup, research ecologist. On staff, I'm also lead scientist for National Program 215 at our lab. So that's me. What's been going on at the GRL? Well, we've 2021 to 22. We're basically doing the same treatments being done in Kansas. That same original 17, was it? Well, when we started this thing, we at GRL added 3 more. So we were at 20. And this year we kind of did everything the same as what was done at K-State, except for 2 treatments. That's the 2 progressive or adaptive treatments, 2 and 3. We're going to plant forage soybean in Kansas. We had one of our extra treatments that forage soybean already. So we said, nah, we're not going to do that. So we went through the pile of stuff that we've been working in the past, and we thought, let's go bring in some forage guar. So we brought in a couple of new cultivars out of Texas that are forage guar to replace the soybean. And other than that, we did add 3 new treatments that were kind of a continuation of stuff we've been doing in the past with novel legumes. Moss bean, tapari bean, some of those types of crops, kind of where we started it. We've been using those kinds of things as a green manure. I thought, well, let's expand this. Let's look at it as a grain crop. Why? Well, if you're going to grow it for a green manure, you got to be able to grow the grain. So what kind of yield do you get? Number 2, these are actually annual grain legumes. They use them to feed people. So maybe we can develop a new crop. So we kind of added that to it. Data collection, we are continuing to do what we did the day we start. We collect biomass at various stages of each growing season of each crop, depending on whether it's either time of year or stage of maturity. For example, wheat, we do one in the fall/winter, one at first hollow stem, one at flowering, one at grain fill. And then the summer crops, we kind of try to do the same thing. Try to stage it out so we get biomass at various times of the year. We continue to do soil chemistry on our plots. Still doing canopy cover type stuff, LAI measurements. And a new one, which Travis Witt came up with, is called Crop Circle, which is a little bit like PhenoChem. So if you want to know anything about it, talk to Travis. Put your hand in there, Travis. I know who you are. Yeah, talk to him. Cool little device. And environmental variables related to the location. One of the problems we ran into during this whole COVID thing, which might be a little different than universities, we got hammered. We got shut completely down. We weren't allowed to do much anything on the lab at all for a couple of years. We kept sampling, we kept processing and drying and getting everything put away where we could deal with it later. And now it's later. The crew told me yesterday that they basically caught up. So we got all of our samples processed, analyzed, scanned through an NIR. It's now just a matter of getting them all through the chemistry so we have our samples completed. There are 3 papers down there. I just thought I'd throw them up there. I know Chuck was talking about papers a little bit ago, but there's 3 of them from this year. The one in the middle is actually out of data that was done by our range student or REU student last year. So there you go. But we're not quite done yet. We also work at larger scales. We have one huge advantage most of everybody in here does not have an S area. We have a 435-acre plot we call Green Farm. We did a redesign of it a couple of years ago to try to make it a little more efficient. And in that redesign, wound up with half of it being used for wheat and the other half open for anything else we wanted to do. So what we decided to do was mimic some of the crop rotations that we have going on in small plot. So, which one's easy? I got the wrong one. Oh, so this year, 40 to 57 acre pastures. We have one of them that's a winter fallow soybean conventional tilled as a control. And we have 2 other soybean crops, both of which involved winter covers. And we did some weird things to the winter covers. One we did not graze, and the other one we said, well, if all of a sudden the price of gain goes up, what's the stocker guy going to do if he's got wheat ground floating around? Going to graze it. So we grazed 1 unit. And see what else did we do in there? Graze sorghum with a grazed winter cover crop, and graze sorghum with a winter fallow. Now, just about all of these things actually have an eddy covariance system on them. So we're doing carbon, water, and energy flux at that soil plant atmosphere interface, and animal when we graze it. There's our times of years, cool seasons, late summer to mid-April. That's kind of where we decided to stop. Summer crops, mid-May to late September this year. For 22 through 23, which is this next cycle, the minute these summer crops kind of come out, we're going to turn around and put some of these things back into a green manure. The winter covers, we just treated like winter cover. We left them as no-till. Next time around, a green manure, you got to get it in the ground. So we're going to turn it up, get it into the soil profile, and then try to follow with some summer crops again. There's a big, long list of data there that we are collecting. EC systems, biomass, we do soil water chemistry, we do canopy cover, LAI, phenocam possibly in the future. Huh? Yeah, we've got the system we haven't set up yet, I don't think. We link a lot of our biomass collections to satellite overpasses so we can go up in scale instead of just sticking it to pasture. Livestock performance when we graze, again, collecting environmental variables. And since this is production scale, we do have what it costs us to grow it and what we get out of it in terms of returns. So there's an economic component to it too. There are problems, and a lot of them Romulo just mentioned. Weed control is becoming a problem in all of our rotations. Timing of operations is a real problem. This year we went from extremely dry to extremely wet about the time wheat harvest happened, and we got delayed about 3 weeks. So it's just part of the system. You get into these weird weather cycles to get you. And we've also got information gaps, which I'm going to throw out there for anybody at a university that's got a student interested. We kind of like to have some feel for what's going on with the weed population and the insect population. Some good folks at OSU did some work on this site probably 5 or 6 years ago, but it was only wheat and canola. Now we're a whole different set of rotations. There might be another opportunity here for you folks to, you know, if you know somebody who wants to get their toe in the water, we got 430 acres. I guess that's it. I need to hit any buttons or just walk away. Down there? Oh, yeah, there you go. This is a little extra one. Last year, Hardeep Singh, who was my postdoc at the time, did some stuff on precipitation use efficiency in winter wheat green manure systems. One of the questions that kept popping up is what happens with soil depths. Since I was the guy actually analyzing that, and I wasn't even close to done when that happened, I'm going to try to get you through this. Upper left is changing soil water from the day you plant your green manure or start a summer fallow to the day it ends. The one on the upper right is when you plant your wheat in the fall till the next spring when you harvest it. So anybody wanted to look at depth, you can see there that nothing's overly efficient at capturing water. But what it shows me when I look at this is that our summer green manures are utilizing water throughout the summer. In that following wheat crop, you have to capture water to actually grow the next wheat crop. Because if you look at it, you kind of conserve water in summer fallow, and you go into the next wheat season, we're using that water. And the legumes in this rotation are the other way around. They use water in the summer. If you don't have any water going into planting your wheat crop, you got to store that water before your wheat will actually go anywhere. But if you look at these things over 5 or 6 years, the bottom right is yield. And as you can see, if you're trying to grow forage, you're kind of in trouble. You're a good 2,000 to 3,000 pounds out per acre. That's a pretty big hit if you're trying to put gains on stockers. But if you look at grain yield, there's only about a 4 bushel difference between the green manures and the wheat itself. So not too bad there, but, and again, that's over 5 years, 2 drought years, 1 normalish year, and 2 wet years. So, when I say wet, I mean like hurricane type wet year. But anyway, I just thought I would throw that up there so people could look at what Hardeep was talking about. This is kind of the backside of it. This is something I have to get done maybe this year. If SAS will ever let me get done with it. It keeps telling me I have a problem in the data. And I tried to open the data set yesterday to work on it. It told me my file was corrupted. So I'm having a great week. And Romulo, someday you're going to look like this with all these systems. Yeah. All right.
Okay. So the plan is that we'll get into objection 2, that's Dyson. I guess quick question or observation, and we're a little bit while Tyson's getting set up here.